So yeah, as Eduardo said, my study is on the Atlas of Unburnable Carbon in Brazil, which is another study that it kind of demonstrates how critical GIS can be used as an effective tool in addressing the climate injustice as well as in advancing the just transition from for fossil fuel transition. So, but first and foremost, what is unburnable carbon? Essentially, with the present day kind of state of the climate crisis, scientists have estimated that significant portions of fossil fuel are needed to be kept underground, so unextracted and unburned, in order for us as a society to have a decent chance at meeting our climate change mitigation targets, namely those discussed in the Paris Agreement. So a number of scientific studies as well as civil society initiatives advocate for this cause, and the most prominent initiative is the Fossil Fuel Non-Proliferation Treaty, which is an international treaty that structures its core principles around three pillars of commitments. So initially we have non-proliferation, which essentially states that we should not expand fossil fuel extraction to new projects and new developments. A phase out of the existing extractions, performed in a way where countries with greater historic responsibility as well as greater economic capability should be the first in line to do so, while also aiding those countries that are less capable in doing so. And finally, transition away from fossil fuels should be performed in a just manner, which essentially means that we should provide alternative sources of energy as well as revenue to every economy and every worker, so no one is affected along the way. So with that being said, our study aims to locate areas where fossil fuels should be left underground by observing the case study of Brazil. Essentially, we know the quantities of oil, natural gas, and coal that are needed to be left underground. The question is where, and we try to answer that question by performing different GIS analysis. But why Brazil? Obviously, Brazil is one of the largest countries in the world, both by its population size as well as by its area. But it's also a country that has very kind of distinctive and very kind of conflicting priorities. Namely, Brazil is one of the largest fossil fuel producers in the world presently. Its oil and gas extraction, in particular, are heavily incentivized by the government, and they're expected to increase for 20% by the end of this decade. Also, Brazil plays a huge role in greenhouse gas emissions, considering that the country is one of the largest CO2 emitters in the world. Simultaneously, Brazil is obviously renowned for its ecological richness and biodiversity, and we know that those ecosystems are kind of heavily pressured. We saw it on the case study of East Africa, but Brazilian ecosystems such as the Amazonian rainforest also play a crucial role in carbon sequestration and thus climate change mitigation. Also, Brazil is a very culturally diverse country, a country that has very kind of rich heritage of traditional knowledge. But as we saw in the case study of Colombia, traditional peoples are very pressured from fossil fuel extraction, and they're usually the communities that are kind of more likely to be on the receiving end of the negative impacts of this industry, whether it is through illegal land encroachments or land grabbing or habitat destruction, which affects their livelihoods. Finally, Brazil was also this year's hosting country for the COP summit. So the largest summit on climate change was held just now in November in the city of Belém, on the outskirts of the Brazilian Amazon. And many kind of saw it as Brazil's attempt to position itself as one of the leaders in battling climate crisis. But as we can see, the administration of Brazil is kind of very, well, it has very kind of distinct confliction in priorities. So that should be taken with a grain of salt. Also, considering that at this point it's kind of a pattern that large fossil fuel producers are hosting the event year after year after year. So essentially, what we did, we constructed this environment in QGIS by uploading a bunch of different open access spatial data as well as other supplementary data. These included sociocultural criteria such as human population, traditional peoples territories, GDP by municipality, health and education facilities, then ecological criteria such as protected areas, priority areas for biodiversity conservation, coral reefs, mangrove habitats, ecosystem services, and much more. And obviously, fossil fuel related infrastructure such as wells and pipelines, as well as resources. Resources were in the form of these licenses. So as you can see on this map, licenses represent these blocks of land or seafloor, which were essentially licensed by the Brazilian administration to the fossil fuel companies, giving them the right to perform production activity, whether it is exploration or actual extraction. And essentially, by utilizing different geoprocessing tools, we wanted to quantify and identify spatial interactions between these oil and gas assets in Brazil on one hand and environmentally and socio-culturally sensitive areas. We kicked off with the overlap analysis, in which we tried to measure areas where oil and gas licenses directly coincide with socio-environmentally sensitive features. And based on the results of the overlap analysis, we constructed these graphs. So these curves are known as the accumulation curves, and the idea of this graph is essentially to communicate the benefits that can be obtained by phasing out smaller portions of Brazil's oil resources. So essentially, with this graph, we estimated that by phasing 13.5% of Brazil's onshore oil resources, you can eliminate all direct spatial overlaps with the country's protected areas. And this is a great benefit at a small cost, considering that more than 95% of Brazil's oil extraction happens offshore, so in the ocean. So essentially, this is 13.5% of less than 5% of Brazil's total oil production. So again, a great benefit at a small cost. However, not every curve came as promising. In the case of the human population, we estimated that there are more than 600,000 people living in the territories of the present-day production fields. And essentially, in order to kind of save or protect all of these people from direct spatial interactions with oil extraction, you would have to sacrifice roughly 90% of Brazil's oil, which is obviously not the greatest amount in the all grand scheme of things, but substantially more than in the previous case. Moving on, we also performed the proximity analysis. So essentially, for this analysis, we wanted to take in consideration the kind of broader, kind of the spatial interactions on a broader sense. So essentially, what we did, we used oil and gas wells, so these pieces of infrastructure, as a source of impact, and we calculated the number of these wells within the 5 kilometer buffer zones around different sensitive areas. And as you can see, the results are in the table. Again, the number of these wells vary across different criteria, but something that was kind of a general pattern in this analysis was the fact that usually there are more production wells within these buffer zones than exploration or other wells, which is kind of something that is very alarming, considering that production activities tend to last continuously for over a number of years. So essentially, these areas are kind of more likely to be exposed to more intense and more prolonged impacts than if it were the other categories of wells. Furthermore, something that we also kind of concluded as a general pattern in the case of the proximity analysis in Brazil is the fact that usually, well, for most criteria, there are substantially more of these oil and gas wells within the 5 kilometer buffer zones than directly inside these areas, which is particularly alarming considering that there were essentially kind of suggest that while to an extent the spatial planning for these oil and gas licenses did include direct spatial overlaps with some criteria to an extent, it completely failed to consider proximities with oil and gas infrastructure such as oil wells, and thus kind of failed to include the full extent of the spatial conflict that exists in these terms and also the full extent of the area of influence that these areas are subjected to. And yeah, based on these different analysis, we concluded there is clear spatial patterns of environmental and social jeopardy in Brazil. Thus, we urge for Brazilian administration to commit to seriously kind of phase down their oil and gas production according to the framework of the Fossil Fuel Non-Proliferation Treaty. So they should essentially start by non-proliferation, especially in those areas that are more environmentally, socio-culturally sensitive. Then a managed phase out of the existing extraction activity. So it should start from those areas that are less economically promising and more environmentally hazardous. And finally, in order to achieve a just transition, we suggest that maybe they should embrace some kind of novel mechanism, such as the Green Royalties Fund. Essentially, these investment funds which would make habitat restoration and habitat conservation more kind of financially rewarding. And this is actually something that was proposed by Brazilian president during the COP summit. It was called the Tropical Forever Forest Fund. So there are kind of attempts to develop these kind of ideas. But I guess the take-home message from this presentation should be the case that Brazilian administration needs to pick a lane, so they can't simultaneously favor oil and gas extraction and nature conservation. In order for them to have a chance at a sustainable future, they need to seriously cut down their fossil fuel productions and thus kind of have an ability to actually prioritize all three pillars of sustainability rather than just the economic one, which is the present case scenario in the country. And yeah, on that note, I thank you for your attention, and I'll be glad to answer any of your questions. Thank you.